Okay, so I've got a spec sheet here for something called the NTI DVI-FO-33-MM.
Not exactly a catchy name.
No, not at all. But it's not the part number that got me. It's the price. We are talking about $430
For a single cable.
for a 33-foot video cable. So, yeah, the mission for this deep dive is to figure out why. Why on earth would anyone pay almost $500,000 for a cord?
Well, it's definitely not for your home theater.
I would hope not.
If you're just hooking up a game console, this is serious overkill. This is an industrial-grade solution, and it's built to solve a very specific physics problem.
Which is?
Copper wire has limits. You try to push a high-def signal over a long copper cable, the signal just starts to fall apart. You get degradation, interference. The picture gets noisy.
Right, so this NTI cable is the fix. The specs call it a hybrid active optical cable. I'm assuming hybrid is the key word there. It's not just glass.
Exactly. It's really clever, actually. Inside that one thin cable, you've got two different things happening side by side. You have 4 fiber optic cores and 5 standard copper wires.
And they split the work.
Yeah, they play to their strengths.
Right.
All the heavy lifting, the actual video data, your RGB signals, the clock sync, all of that gets turned into light.
And shot down the fiber optic lines.
Right, because light doesn't degrade over distance like an electrical signal does. It's just cleaner, faster. They're using a tiny laser, an 850 nanometer VCSEL, to handle that data.
And that's how you get that 1.65 gigabits per second bandwidth without any glitches.
Without any pixelation, any snow, even at 33 feet. Or much further.
Okay, but then why keep the copper? Why not just make the whole thing fiber optic?
It's for the handshake. Your computer and your monitor, they need to talk to each other.
Oh, right, the DDC. The display data channel.
Exactly. The monitor has to tell the computer, hey, I'm a 1080p screen, send me that resolution. That kind of communication is really low bandwidth. Copper handles it perfectly fine.
So using copper for that part keeps it simple. It lets the whole plug-and-play thing still work.
You got it. The lasers do the heavy video lifting, and the copper handles the, let's call it, administrative tasks.
That makes sense. It explains the how, but I want to go back to the why.
Yeah.
You mentioned interference. The source material talks a lot about high-noise environments.
And that is the absolute biggest selling point. A copper wire is an antenna. A long one is a good antenna.
So it picks up stray signals.
It picks up everything. Radio waves, EMI for machinery. If you run a long copper DVI cable across a factory floor near an MRI machine, you're asking for trouble.
And that shows up as static on the screen, flickering.
Or a complete signal dropout. But fiber optics, they transmit light. They're physically immune to all that electromagnetic noise. You could wrap this thing around a power generator and the picture would be rock solid.
Which lines up perfectly with the use cases they list here. Medical imaging is a big one.
Of course. A surgeon looking at a live feed can't have the screen glitch out.
Or what about airplanes? They mention onboard video systems. The amount of electronic noise in a cockpit must be a nightmare.
It's an absolute nightmare. Same with TV broadcast stations. In those places, $400 isn't a cost. It's insurance. Zero signal loss is a requirement.
What's surprising, though, is that it does all this without an external power brick. Active cables usually need to be plugged into the wall.
That's the elegant part. It just sips the tiny amount of power it needs directly from the DVI port. So for the user, you just plug it in like any other cable. No drivers, no power supplies, nothing.
So to answer our opening question, you aren't paying for 33 feet of cable. You're paying for reliability.
You're paying for a guaranteed crystal clear image in a chaotic environment. And for scalability. We're talking about the 33-foot version, but this tech goes up to 100 meters. That's over 300 feet.
That really changes how you can design a space, whether it's a hospital or a broadcast studio. It's wild to think about the invisible tech holding our world together.
It really is. We all obsess over the screen, the 4K resolution, the OLED panel.
But not the pipe that gets the data there.
And that's the thing to leave with. The next time you see a perfectly clear image on a medical display or a giant digital sign, just remember that image might be completely dependent on a tiny beam of light, flying through a cable no thicker than your finger, totally ignoring all the electrical chaos around it.
A great thought to end on. Thanks for breaking this down.
My pleasure.